Hi all, welcome to a short video clip when we'll be looking at representing data with box plots, or what they're sometimes called box whisker diagrams. Now this builds on what we were doing before half term when we were looking at the interquartile range and the median of a data set. And to draw a box plot we need 5 values. We need the lowest value and the highest value. We need the lower quartile and the upper quartile, and we need the median. And here's an example of one here. The best thing to do is to draw the box first. So for that I need the lower quartile, which is 32, and I need the upper quartile, which is 50. And that enables me to draw the box. Once I've got the box, I can put the median in it, and the median is 36. And since I'm using a scale of 1 box is 2 units, that's 3 boxes above the 30 and 2 boxes before the 40. And then all I've got to do is extend the whiskers to the lowest and the highest value. So I drag a whisker down to 24 and I drag a whisker up at the other end up to the highest value, 60. And so we've got our measure of location, our average, the median, is 36, and notice that it's not necessarily in the middle of the box. And we've got our measure of spread, the interquartile range, which would be 50 minus 32 to give us 18. Now you're not always given the 5 values that you need, so here's another example. And in this example we're given the lowest value, the lower quartile, the median, the interquartile range and the range. So the two missing, we haven't got the upper quartile and we haven't got the highest value, but we can calculate them because the difference between the lower quartile and the upper quartile is the interquartile range. So the gap between those quartiles is 20 in this case. So if we add the 20 onto the lower quartile, we'll get the upper quartile, which would be 48. And if we add the range, that's the distance from the lowest to the highest, if we add the range onto the lowest value, onto the 20 plus 36 will give us 56, and that will tell us where to do the top whisker. Now what's actually happening here is the data's been split into 4 groups. The bottom quarter, let me draw it in, that's the bottom quarter of the data. The second quarter up to 50% takes us to the median. The third quarter up to 75% takes us to the upper quartile, and then the top quarter takes us to the highest value. So you always need to bear in mind that a box plot splits the data into 4 25% blocks. So why do we need these diagrams? Well, you need these diagrams to compare data sets. So here's an example. We're going to compare some exam results for boys and girls. So we've got our 2 box whisker diagrams, and you'll notice I've said here we always compare the medians as a measure of location. That's an average. And we compare the interquartile ranges as a measure of spread. So forget about the range, because the range is distorted if you have one big value or one small value. The interquartile range looks at the middle 50% and gives you a much more sophisticated idea of how spread out the data is. So what do we say? Well, we want 2 comparisons every time. First of all, we look at the average, and it's absolutely vital that you start this with saying on average. On average, the girls perform better than the boys, since they had a higher median 42 compared with 38. So there's the girls' median 42, the boys' median is only 38, so end of story, the girls perform better. If it had been a race, if they'd been doing the 200 meters, obviously the smaller time would have been better, then the boys would have been performed better. But in most examples we look at, the higher value is best. So on average the girls perform better than the boys. The other comment we have to make is on the spread. And here we're talking about the interquartile range, and it's a matter of just looking to see which is the biggest box. And you can see the girls have a large wide box, the boys a much narrower box. So I've said here the boys' results were more consistent than the girls because they had a lower interquartile range. The width of their box is only 8 units, the width of the girls' box is 14 units. Now, it isn't a case of it being better or worse, it's just different. And there's two ways I can say this. I could say the boys' results are more consistent than the girls', or I could say the girls' results are more varied than the boys'. But I must make a specific reference to the interquartile range, saying what they are so I can compare them. And now it's time for you to try and put this into practice on an exercise of 5 questions. And I'd like you to complete the questions and send them to me by Wednesday. You can do them in your exercise book using the squared paper, or you can print them off at home if you've got that facility with a printer. That's it for now.